Welcome to the codeItDown. This is Munish Kumar Verma, your Java trainer. Today we'll be learning about sorting algorithms. Am I audible, guys? Okay. So, okay. So let's start. Today we'll be learning about the sorting algorithms. Okay. I'm sharing my screen. So, is my screen visible? Yeah. So, in today's session, we'll be covering the topics that is what is sorting, three types of sorting, that is selection sort, insertion sort, and quick sort. We have more than three types of sorting, that is more than 7 to 8 types of sortings, but today we'll be learning about these three types. Okay, so first of all, let's start it by knowing what is sorting. Anybody knows what is sorting? Anybody? Arrangement. Yeah, in order. Correct. So let's start. Oh, sorry. Okay, so as you said, sorting is an arrangement of elements, right? That is, arrangement means it means that we are arranging the elements in a certain order. Okay, like a decreasing order, increasing order. Okay, so that's what sorting means. Okay, so we'll be learning about three types of algorithms, sorting algorithms, and all the algorithms are based on arrays. In that is, we'll be doing operations on arrays, so it will be far more easier for you all to understand what is it. Okay, so let's start with insertion sort. Okay, in insertion sort, the array is split in two parts. Okay, the first part is unsorted part and another part is sorted part. Okay, and then the elements from the unsorted part are placed in the correct position in the sorted part. Okay, like take an example, that is my screen visible? Yeah. Okay, so here the array is given. Let me use the pen first. Okay, this is the given array: 4, 3, 2, 10, 12, 1, 5, and 6. As you can see that this array is unsorted. That is, it's not arranged either in decreasing order or in increasing order. Okay, so we'll be using an insertion sort here to sort this given array. Okay, what it does? It, since the whole array is unsorted, right? So to sort the array, we'll be choosing the first element and comparing with it with the next elements and finding it which is the minimum element. Okay, and placing it in the correct position. Like, take an example here: 4 and 3. Okay, since 4 is greater than 3, so since we are arranging in increasing order, right, that is, the first element should be smallest and the last element should be the largest. Okay, so since we are arranging the elements in increasing order, what we'll do, we'll compare 4 and 3, and since the 3 is less than 4, the 3 will come before the 4. Okay, as you can see in the third step. Correct. Okay, and similarly, now the element 2 is smaller than 4 also and 3 also. So first 2 will be compared with the element 4, and since it is smaller than 4, it will come before 4, and since 2 is also smaller than 3, it will come before 3, right? So as you can see in the fourth step, first 2, then 3, then 4. So as you can see that this part There is the first part is sorted part, and this part is unsorted part. Okay, as in the definition I speak about it. So next element is element 10. Okay, this one. So since 10 is larger than all the elements, that is 2, 3, 4, so according to the fifth step, that is a step still now, the 10 is in correct position. We'll be moving after it, after we'll moving in the next steps to see, to check if this is correct position for 10 or not. Okay, for up to this time, up to this step number 5, the 10 is in correct position. Okay, so now the next element is 12. Okay, so 12 is also in the correct position because the elements before 12 are arranged in increasing order, and no element before 12 is greater than 12, right? Because 2, 3, 4, and 10 are all less than 12. So coming to the next element, this is the sixth step. Here the element is 1, right? 1 is smaller than 12, 10, 4, 3, and even 2 also, right? So 1 should come at the first. Okay, so 1 should be coming at the first position. So according to the given array, the next step in the seventh step, the array, the first element is 1, then 2, then 3, then 4, and then 10, and then 12. Okay, because 1 is smaller than all the elements before it. So coming to the seventh step, the next element is element value is 5. Since 5 is smaller than 12, it will come before 12. Also smaller than 10, so it will come before 10. And but it is greater than 4, right? It is greater than 4. So this will 5 will come in between 4 and 10. So as you can see in the eighth step, the elements on the left side till 12 are arranged in the correct position. Okay, and the next step is, and then sorry, next value is 6. So as we know that the 6 will come between 5 and 10. How? Because 6 is smaller than both 10 and 12 but is larger than 5, right? So in the ninth step, you can see the whole array is sorted, right? So shall we move to the coding part? If you have any doubts, please ask. Okay, so let's move towards the coding part. I'll be sharing my screen. Okay, is my screen visible? Is my screen is visible? Yeah. So let's make the main function first. Public static void main. Okay, we'll use an array int a. So new int. Let's assign it here. No, let's make it like this. Int a equals to new int of size. Let take it as 8. Okay. So for taking the input, we'll be using the buffer reader here. Okay. Buffer reader br equals to new system.m. Okay. Since we're using the buffer reader, we'll be throwing the exception here. That is IO exception. Let's make it as exception only, because IO exception is a subset of exception class. So let's take all the elements in one line. So for using this, we'll be using this code read splitting all the elements in the one line using the space, and after that we will be storing all the elements in the array A. This is the basic part. We haven't come to the insertion. Okay, so and I equals 0, I less than a dot length. What is the length of A? Then I plus plus. After that, A of I will be integer dot pass, and we'll be passing the string elements into integer. Okay, so here we took the input. Okay, so let's get to the next step. Void insertion. Let's make this method public first. Then we'll be passing, what will be passing? We'll be passing the array here. Okay, and then for int, oh, okay, for int I equals 0, I less than a dot length. A dot length means the element till the last, okay, from 0 to the last index. Then we'll be using a temporary variable to store the first element, the ith element. Okay, let's take it as int ele. Okay, equals to a of I, that is storing the ith element that is in each and every iteration of the loop. Okay, and then we'll be using a next variable j to store the I minus one element. Okay, to store the index of I minus one. So for the index 0, I minus 1 will be j equals to minus 1. Okay, I minus 1. Then we'll be using the for loop, which will be run from j equals greater than equals to 0, and and also if a of j is greater than ele. Okay, I'll be explaining the code in the later part. First, let me write it. Okay, so a of j plus 1, here we are swapping the elements, equals to a of j, no, not swapping here, a of j plus 1 equals to a of j. Here we are arranging the elements, swapping isn't here. Okay, we are arranging the elements. Okay, then j equals to j minus 1. Okay, after that a of j plus 1 equals to ele, right? So here we took a temporary variable, we took to store the to store the ith elements value. Okay, temporary variable j to store the index, to store index, and then while loop with the condition j greater than equals 0 and j is greater than equals to element. Okay, so that is like if the 1 2 0 are there, and if we are comparing 2 and 0, since 0 should come in the first place, so like take an example here, like 3 1 and 2, right? So since 1 is here, 1 should come before 3, right? So in the next step what will happen, it will be like this: 1 3 and 2, because 1 is less than 3. That's what happening is here. Okay, that's what happening here. We are arranging the elements 1 till all the elements after 1 are greater than 1, right? So here we can see here that 1 and the elements before 1 can be either 0, that is no elements, or less than 1. Okay, that is, it can be 0. So let's take in the next step, it will be like this: the 2 will be comparing 2 here. Okay, 2 is less than 3, so 2 will come like this: 1 2 and 3, right? Is it clear? So let's print it. let's make a print function here. A. Let's make it here only. 0 less than A dot len. And here we'll be calling the insertion. Okay, let me make it static. Okay, static. Okay, so let's see what happens. Let's mm, 7, 12, 3, 22, 4, 5 elements. Okay. 1, 3, 2. 1, 2, 3, 3, 4, 7, 2, 2. So as as you can see that the elements are sorted here. Yeah, what's the question? Why a of j plus 1? Okay, see, this is the element at a of j plus 1, right? So we are gonna exchange the element 1, line number 40 versus line number 46. Okay, okay. So after the iteration, after completion of the while loop, to enter the next element, right? To enter the next element, that is a of I plus 1, we're using a of j plus 1, because a of j plus 1, here you can see that I minus 1, that is the zeroth element here. Okay, and after this j equals, again j will be j minus 1, right? So the next element will be I plus 1. It's a bit confusing, right? Okay, let me explain it once again. Here a of j plus 1 refers to the next element after the sorted part. Okay, so here you can see 1 3 are in the sorted part. So for this element 2, a of j plus 1 will be 2. Okay, here, so 2 will come here. After sorting, 2 will come here. So new a of j plus 1 will be 3. We can't compare it in the original array, right? This is the original array. If we are comparing in here, it will be 2 every time, right? First 1 and 2, which is wrong. But to compare it in the array that we are sorting, we have to do this, correct? Yeah. So let's move to the next sorting. Is it clear? Okay. So next one is selection sort. Okay. It sorts the array repeatedly. How? By swapping it. Okay. It swaps the minimum element at its correct position. Okay, it swaps the minimum element at its correct position in the sorted part. What is sorted part here? Like take the this third line. Okay, the sorted part is 7 9, right? So the element from the unsorted part, that is 11 10 and 12, the element that needs to be sorted, the minimum element after 9 will be, so will be come in the, will be swapped with the 16. Okay, let me explain you how it's happening. Okay, take the first step here, this one. Here what, the first element is 12. So to swap the element 12, we need to find the minimum element, right? The first minimum element will be 7, right? First minimum element means, like if you have 1 2 and 3, I'm using the first minimum element word so that you can get what I'm saying in easy way, right? First minimum element means in the element of 1, 2, and 3, first minimum element will be 1, second minimum element will be 2, and third minimum element will be 3. Okay, so first minimum element in the first tab is 1. Okay, is sorry, is 7. Sorry. So will swap 7 and 12. Okay, so in the second position you can see 7 is in the correct position, that is we are increasing we are arranging or we are sorting in increasing order. So 7, the element 7 or the value of element 7 is in the first position, and 12 is at the last position, that is both 7 and 12 are swapped. So coming to the next element of index I equals to 1 is 10, right? So next minimum element, second minimum element will be after 7, the element greater than 7 but smaller than all will be 9, right? So 9 is being swapped with 10, right? So in the next step, it is third step, you can see 7 then 9. Again 10 is swapped, so 10 is at the place of 9 and 9 is at the place of 10. Okay, that's what swapping means, that is exchanging the places, correct? So in the third step you can see element 16 and element 10. So third minimum element is element 10, so 16 and 10 will be swapped. Okay, so the new array will be 7 9 10, that is the sorted part. And then again, so next minimum element, that is fourth minimum element will be 11 only, because 11 is the fourth minimum element and all the elements are greater than 11 are 16 and 12, so no swapping here. Okay, 11 is at its correct place. Coming to the fifth minimum element is 12, right? So 16 and 12 are swapped. So in the sixth we have our sorted array, that is 7 9 10 11 12 and 16. uh, you have any questions regarding swapping, please ask, or regarding the selection sort? Do you have any questions? Okay, let me explain you once again. Okay, here let me clear it all. Okay, here the first minimum element is 7, so 7 is being swapped with 12. Then next minimum element is 9, so 9 is being swapped with the second element, that is 10. At the third step, the third minimum element is 10, so 10 is being swapped with the index I equals to 2. Okay, and the fourth iteration, the next minimum element is 11, so 11 is not swapped because 11 is at its correct place. Okay, so in the fifth iteration, 12, right? 12 is the fifth minimum element. Okay, so 12 is being swapped with 16 to come at the place of I equals to 4. Okay, and then in the sixth iteration the whole array is being sorted. Okay, so simply we can say that in the selection sort the minimum elements are being sorted in such a way that all the elements are being arranged in the increasing order. Okay, we have to choose a minimum element in each and every situation, what we say, in each and every iteration, so that all the minimum elements or all the sorted elements come in the left side of the array. Okay, so let's start with the coding part. Is my screen visible? Yeah, so let me comment the insertion sort first so that I can explain you the selection sort code. Okay, let's start in public static void selection. Okay, we'll be passing the array here, int a. Yeah, one more thing, right? The time complexity of insertion sorting is O of n square, right? Why O of n square? Because we are using two loops, okay? The worst case will be O of n square, and even the best case will also be O of n square. Okay? So for selection sorting, also this will be O of n square in whether it is the best case or the worst case. Okay? So let's start with the selection sorting algorithm. First, we'll be iterating through all the elements, right? So for that, we'll be using the for loop I equals to z till last element a dot length. Okay, I plus plus. Then we'll choose a minimum element. Okay, I. Okay, that is the index. Okay, not the element index. What is the minimum index? That is the ith index. We are assigning the ith index as minimum. Okay, then we'll start the next for loop into j equals to I plus 1, because we have to sort the elements after one first element, right? That's why j equals to I plus 1. We'll be starting from the I plus 1. Okay, then j less than a dot length till the last element, then j plus plus. Okay, so if element at a of j is less than the element at a of I, right? That is a of minimum. I've used this minimum variable so that it will be easier for you to understand from which element I'm comparing it. Okay. Okay. So a of minimum, then minimum will be j. If a of j is less than a of minimum, so minimum will be j. Okay. After this iteration, after the whole iteration, what we'll be doing, we'll be swapping the minimum element with the element that we're comparing. Okay, I'll give you one example here. Let me write the code for the swapping. I'll be using a temporary variable method. Int temp equals to a of minimum, then a of minimum equals to a of I, and then a of I is equals to temp. Okay, so here we have swapped the elements. Okay, variable to store the index of current element. Okay, okay, so let's start here. Take an example of 31 to 133. Okay, so at first iteration, that is I equals to 0, the zeroth element is, that is minimum index is 0. That is the, you can see 39, line number 39, the minimum index is 0. So we'll start it as 31 will be compared with all the elements after it to find the minimum element. Okay, so we'll start from the a of I plus 1. Okay, then 2, 1 and 33 are the elements after 0, right? Yeah, what's the question? In insertion sort, the unsorted part consists of one element. uh, can you explain your question? Can you explain your question, please? You mean after the whole iteration you're saying that? After the whole iterations, I think all the elements are sorted. That's why we call it a sorting method, right? Like in selection, we have minimum element as first element. Yeah. Selection short, we have the minimum element as first element. Yeah, we have minimum element as first element, not the first element. We are using the minimum. Yeah, you are getting confused in the line number 39. Is that it? Are you confused in? Okay, okay. Let me explain you. Okay. In the line number 39, I have simply written a simple code for what? Let me tell you. Okay. Here, I have assigned the value of I, that is 0, to, because this value will be helpful while swapping, right? We have to swap with the 0th element. Like in the iteration number 1, after this, what will happen? The value of I will be 1, right? So this will look like this. Let's take another example here. This will look like this, right? After this iteration, this will look like this. So in the first iteration, the element 1 is the minimum element. So first iteration will be comparing with the 0th element, that is the 39. So to swap the element 31 and 1, we have to store the value of I, right? Here we are doing the swapping, right, with the minimum index, that is 0th index, correct? Right? Are you getting my point? I've used this because I have to swap the elements, right? At here and here. Yeah. Let me explain you again, okay? Here I've used the minimum variable to store the index of the ith element, okay? So in the first iteration, the ith index is 0. So I have to swap the 0th element with the element whose value is minimum, right? Here in the I plus 1 part, it is this part. In this part, the minimum element is 1. So I have to swap the 1 with 31. So to swap both the elements, I have to know the index of both the elements. To know the index of 1, I'm using this for loop. And to store the index of 31, I'm using this variable. And since I know the index of 31 and 1 also, I can swap it here. Okay, you got my point? Okay, let's see. Okay, 12, 2, 1, 33, 11, 4, 10, 8. Okay, so as you can see that elements are sorted in the ascending order. Is that clear? Is that clear? Shall I explain it once again? Okay, let me explain it once again. Okay, here in the selection sort algorithm, what we do, we first find the minimum element in the whole unsorted part. Okay, we take this first element is sorted element and the whole elements are unsorted elements, okay, in the first iteration. So in the first iteration, we store the index of 31, that is the first element will be 0, index will be 0. And the second for loop, while using the second for loop, we find the minimum element, that is 1 in this part, 2 to 30 part, right? And we store the index of the minimum element in I plus 1 to a dot length part, right? I plus 1 will be here, okay? It is from 1 to last index, okay? After finding the index of the minimum element, and as we also know, we in the first iteration, that is 0th iteration, we have to swap the first element with the minimum element, right? For swapping, we are using this part, okay? Okay, let me write it. Swapping minimum element in every iteration. Okay. Okay. Let's start with the next one. That is quick sort algorithm, and the last algorithm will be. So, as you all know, today is the last session for the Code It Down season 2. So we'll be connected through the groups, that the WhatsApp group. So if you have any questions regarding each and anything, you can ask whenever you want. Okay, guys. So let's move to the last topic. That is quick sort algorithm. Is my screen visible? Is my PowerPoint screen visible? If you not give the answer, how can? Okay, so let's start. Okay. Oh, okay. Give me a second. Give me 1 second. Okay, so let's start. Okay, so in quicksort, what is quicksort algorithm? Anybody knows what is quicksort algorithm? It is also sorting algorithm, obviously. What we do here? No. Okay. See, in quicksort algorithm, what we do, we take an element as pivot element. What is pivot element? Any element which is common for any element's position, right? Which is common in each and every iteration. Element's position I'm talking about, not the element. Okay, which we'll be using to sort the whole array. That's we call it as pivot. Okay, so it is a, first of all, it is a divide and conquer approach. Okay, what is divide and conquer approach? Divide and conquer approach refers means we'll be dividing the whole array in its subparts and then we'll be conquering it. It's what means conquering, we'll be sorting it. Okay, here the conquer refers to sorting. Okay, everybody knows what is divide and conquer. We'll be dividing the whole array, then we'll sort all its sub arrays, okay, one by one. So how are we doing that? What we'll do, we'll take one element as pivot first. Okay, we'll partition the whole array according or around the pivot element. Okay, it can be the first element, last element, or any random element, or the median element. What is the median element? Middle element. Okay, middle element. Okay, so let's start it. If after some time the if meeting gets over, please rejoin using same link. Okay, okay. I'm audible. Yeah, hello. I think I'm not audible, right? Anyways, the meeting will get over in few minutes. Okay, so rejoin using the same link. So let's start the quick sort algorithm. Okay, so take okay, so take this in as an array, the given array 10, 80, 30, 90, 40, and 50 and 70. Okay, so here we are using the pivot as last element. Okay, as you seen this, we're using this one, the last element. You can use any one, okay? That is the first, last, random, or median. So let's start, okay? So for the given array, the last element is 70. Okay, so we'll be partitioning around 70, correct? So what do you mean by partitioning? First of all, partitioning around 70 refers the elements at the left hand side of the 70 will be lesser than 70, and the elements at the right hand side of the 70 will be greater than 70. Okay, is that clear? Yeah, dividing. Yeah, correct. Dividing. So how will be dividing? Here dividing refers the if element 70 is pivot, the last element is pivot. So we'll be partitioning or dividing around 70 such that the element at the left hand side of the 70 will be less than 70, and the element at the right hand side of the 70 will be greater than it. Okay. So let's start. So we have partition around 70. So you can see that 10, 30, 40 and 50 all are less than 70. Okay. While 80 and 90 are greater than 70. Okay. So let's partition in the, so coming to the left hand side, we'll partition around 50. If we partition around 50, all the elements are smaller than 50. Okay. Again, the last element is 40. So all the elements less than 40 will be 10 and 30. Again, partitioning on 30, the element less than 30 is 10. So we can see that 10, 30, 40, then 50. First, the first element will be 10, then 30, then 40, then 50. Okay, according to this one. Okay, and then 70. 70 is the pivot element. Okay, and coming to the right hand side, the last element is 80. So we'll be partitioning around 80. That means 80 here, and 90 will be, since 90 is greater than it, right? So 90 will be coming to the right hand side. Okay, as we already know, if the pivot element is less than the given elements, it will be the left hand side, as you can see in here, and the element greater than the pivot will be at the right hand side. Okay, take an example here, that since 80 is less than 90, sorry, since the pivot element is 80 and 90 is greater than the pivot element, it will come in here in the right hand side. Okay, while here the pivot element is 50 and the elements 10, 30 and 40 are smaller than 50. Okay, so they are coming in the left hand side. So after the rearrangement, it will be like this: 70, then 80, then 90. Okay, let me explain you again if you're confused. Okay, so this is the given array: 10, 80, 30, 90, 40, 50 and 70. What we'll do here, we'll see the element numbers as pivot element is 70. That is the last element. We are taking it as pivot element. Okay, so we'll be partitioning around 70. So the elements less than 70 will be at the left hand side. Okay, and the elements greater than 70 will be at the right hand side. Okay, so elements less than 70 are 10, 30, 40 and 50. These are the elements less than 70. Elements greater than 70 are 90 and 80. Okay, again in the left hand side we can see that the pivot element or the last element is 50, right? So we'll be partitioning around 50. There are no elements greater than 50, so 50 will be last element, and 10, 30 and 40 are less than 50, so this will come at the left hand side. Okay, again we'll be partitioning around 40. Why 40? Because 40 is the last element in the next sub array. It is a 10, 30 and 40. So 10 and 30 are smaller than 40. So coming to the left hand side, and in the right hand side it will be 40. Correct? Again, the new sub array is 10, 30. So 10 is smaller than 30 and 30 is the pivot element. So 10 will be in the left hand side. Okay. Coming to the next part. Here we have arranged the elements like this: 10, 10, 30, then 40, then 50, and the first pivot element, that is 70. Okay, now we have arranged more than half of our array. After that, we'll come to the right hand side and we see that 90 and 80 are the two elements in the right hand side, right? So last element here is 80, correct? So what we'll do here, first we'll conquer the whole, we'll divide the sub array 90 80 in the around 80th element, and since 80 is left, 80 will come to the left hand side. Why? Because it's smaller than 90. Okay, so it will be like this: 80 then 90. Okay, so is that clear? Yeah, so let's move to the next, that is the coding part. Okay, is my screen visible? Okay, okay, let me comment this. We'll be starting with the quick sort. Okay, so in quick sort will be, what will the first step? First step is partitioning, and second step will be, what will the second step? Arranging, right? So first we'll partition around a pivot element, right? Okay, yeah, so let's start. Okay, first I'll make the function partition, public static and partition. Okay, int a, what is int a? It's the array of the element. Okay, then int low is the zeroth element. Okay, we are taking as low and high. Okay, so that we can change the pivot elements as we want. Okay, int high, let's take it as h. Okay, so since we are taking the pivot element as the last element, right? So last element will be int pivot equals to a of h. Okay, and the lowest element will be low minus 1. Why low minus 1? Why low minus 1? Because the lowest element is l equals to 1. Okay, l minus 1. Then we are going to, okay, let's wait for 2 minutes for others to join. Okay, let's wait 1 more minute. Okay, am I audible, guys? Am I audible? Okay, is my screen visible? Yeah. Okay, so we were at the partition part. Okay, so we are taking the pivot element as the last element. That's why we written a of h, last element. Okay, and I will be starting the process from the zeroth element, right? So for int j equals to low, right? To j, low means L, that is the first element. To j less than h, there is the last element, j plus plus. Yeah. Okay. If a of j, right, this is the element at jth position, is less than the pivot element, right? So what will happen? It will go to the left hand side, right? So it will go to the left hand side, okay, and will be increasing the ith. Okay, so what will happen here? We'll be swapping here. Okay, okay, swapping, not swapping, arranging the element around pivot. Okay, arranging is simply a swapping in different way. Okay, here int temp equals to a of I, and then a of I equals to a of j. Okay, a of j equals to temp. Okay, this is a simple code of swapping, everybody knows, right? Up to this part, is it clear? This is the if part. Is this clear? If part, what is this part? Yeah, let me tell you again. Okay, what here we're doing, the element at left are smaller than element at right. Okay, so we have arranged the element at the left also. So now we have to arrange the element at right, right? So for that, again the swapping should be done. Okay, so swapping will be like here, int temp equals to a of I plus 1. That's why we are using I. Okay, so that we know the position until when we have to stop. Okay, I will explain you this part again. And then a of I plus 1 equals to a of h, then a of h equals to temporary variable, and we'll be returning I plus 1. Okay, so this one is element greater than pivot. Okay, is that clear? The partition is clear. Okay, let me give you an example here again. Like the pivot is 5, the last element 1, 30, 232, 5 is the pivot, then 51, then 4. Okay, so pivot element is 51 first. So in the next iteration, what will be like this? 1, 5, and 4 partition around what, 51, and in the right hand side we'll be having 232, right? Then for the left hand side 154 will partition around 1, then 5 partition around 4, right? Then again it will partition around 1, that is 5 will be partitioning around 5, 1, then 5. Okay, so the partition is complete here. So let's move towards the sorting. Okay, public static void q sort. Let's take it as a quick sort. Okay, quick, will be passing array, correct, int a, int l, that will be the smallest index, that is 0th index, then int h, that is the last index. Okay, if l is less than h, yeah, it's simple condition to check. Okay, then we'll be partitioning around the pivot element int pi. Int pi will be getting the pivot element through partition, right? So this, so we'll be calling the partition. Okay, and then after that we'll be sorting around it quick. Okay, so yeah, this is the part. P of I, P of pi minus 1. Why pi minus 1? This is the left hand side and this is the right hand side. Okay, P of I plus 1, P of pi plus 1 till high h. Okay, okay, right side, left side. Okay, so let me tell you what's happening here. Since here you can see that we are partitioned around 51. Okay, so pi is 51 here. Okay, and then the element at the left hand side are p of I minus 1, because the index of pivoted element will be from low to pi minus 1, that is the 0 to pi minus 1, and then after this there is I pi plus 1. Okay, after 51, so till the last index, till index 5. Okay, let me give you another example. 0 1 2 3 4. Okay, since only one element is larger than 51, okay, so it will come to the right side, pivoted around 51, there is an index will be 3. Okay, then again the right hand side will be pi plus 1 to the last index, that is 51, not 232 the last index, and 232 is at the last index only, and this part shows from 0 to index before 51, that is 2. Okay, so let's call it quick. Okay, yeah, what will be in the place of this h? Anybody can guess it? Yeah, n minus 1, correct one. 0 to a dot length minus 1. Okay, take it as n minus 1. Yeah, okay, so let's run it. 12 1 23 34 12 10 2 elements 46 15. Okay, so is it clear? As you can see that we got the answer correct. Okay, so if you endorse, if you have any doubts, please ask, or you can post it in the group or code it down group. Okay, Okay. So thank you everyone for joining the meeting, for joining the class. Okay. Good night, goodbye, and stay safe. I'm ending the meeting. Okay.